Hi dear students, this particular class I want to discuss another idea in the circle chapter, that is pole, polar, and what about the conjugate lines, and then I will discuss about radical axis and radical center, right? So this is a circle. Let us say the circle equation is S is equal to 0. So P x1 y1 is an external point. Through this external point a secant line is drawn. The secant line cuts the circle at A and B. Through this point P, these type of lines, how many we can draw? Infinite number of lines we can draw. You can observe this is a circle. Here there is a point P x1 y1. This is one line, another line, one more line, one more line. So like this we can draw infinite number of secant lines. Okay, right. Through this point P x1 y1 a secant line is drawn, meets the circle at A and B. At A tangent is drawn. At B also a tangent is drawn. The locus of point of intersection of these tangents, because these type of lines, so many lines are possible, then these type of points also so many are possible. All those points, all these type of points lie on a straight line. All these type of points lie on a straight line. That line is called, this line is called polar. This line is called polar of a point P x1 y1 with respect to the circle S is equal to 0. Once again, through the point P x1 y1 a secant line is drawn, meets the circle at A and B. Tangents drawn at A and B intersect at a point. The locus of this point lie on a straight line. That straight line is called polar of a point P x1 y1 with respect to the circle S is equal to 0. The equation of this polar, the equation of this line is given by S1 is equal to 0. So when the point P x1 y1 is outside the circle, polar meets the circle at 2, polar cuts the circle. When the point P x1 y1 is outside the circle, polar intersect the circle. But when the point P x1 y1 is, okay sir, when the point P x1 y1 is outside the circle, polar intersect the circle, right? Then the equation of the polar is S1 is equal to 0. This S1 is equal to 0 is nothing but chord of contact of a point P x1 y1 with respect to the circle S is equal to 0. But what happens when the point P x1 y1 lies on the circle? When the point P x1 y1 lies on the circle, then the equation of tangent at a point x1 y1 is nothing but the polar. If the point P x1 y1 lies inside the circle, yes, through this point P x1 y1 we can draw infinite number of tangents. Now these tangents, at these tangents we can draw, at this point of contact we can draw tangents. Now these tangents intersection point lie on a straight line, lie on a straight line. This is called the polar. That means P x1 y1 is an external point, polar cuts the circle, then the equation of polar is nothing but S1 is equal to 0. That is nothing but the chord of contact of a point P x1 y1 with respect to the circle. If the point P x1 y1 lies on the circle, the tangent at a point P x1 y1 is nothing but the polar. If the point P x1 y1 lies in the circle, lies inside the circle, then the polar does not intersect the circle. Now this point P x1 y1 is called pole of this polar with respect to the circle S is equal to 0. So as we discussed, this is the point Px1, y1. A secant line is drawn, meets the circle at capital A and B. At a point A, we are drawing the tangent. At a point B also we draw the tangent. These are tangents intersection point locus, we are calling it as polar. Okay, so this is the polar. The equation of this polar we discussed as S1 is equal to 0. Now here what I am doing is I am taking a point on this. Let us say this particular point is Q. This point is Px1 y1 and this point is Qx2 y2. What we are observing, Px1 y1 and Qx2 y2, the polar of a point Px1 y1, the polar of a point Px1 y1 passing through the point Qx2 y2. Similarly, for the point Qx2 y2, you will find out the polar passes through the point Px1 y1. The polar of P passes through Q. Similarly, the polar of Q passes through P. Then these two points are said to be conjugate points. You know that the polar equation is S1 is equal to 0. That is nothing but x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0. That is the equation of the polar. Now this polar is passing through the point x2 y2. Substitute x2 y2 there. That means in place of x, x1 x2. In place of x I am writing x2. In place of y we are writing y2. That means y1 y2 plus g into x1 plus x2 plus f into y1 plus y2 plus c is equal to 0. So these two points are said to be conjugate points. Px1 y1 and Qx2 y2 are conjugate points with respect to the circle S is equal to 0. Then we can say S12 is equal to 0. 2 points are conjugate points. Then S12 is equals to 0. Then these are two lines, because this is one line. Similarly, you will get the polar here like this. For this point Qx2 y2, this is the polar. Now these two lines are said to be conjugate lines. That is about conjugate points and conjugate lines. This is a circle. Let us say this circle equation is S is equal to 0, and this is another circle. Let us say this circle equation is S dash is equals to 0. Right? What is a power of a point? As we discussed in the earlier classes, Cp square minus R square, which is nothing but S11. Cp square minus R square is nothing but S11. S11 is called power of a point with respect to this circle. Now here there is a point, power of this point with respect to these two circles same. Power of a point with respect to these two circles same. Let us say this point power with respect to the circle is S11. Power of the same point Px1 y1 with respect to this circle is S dash 11. These two are equal. Power of a point with respect to these two circles are equal. Then these type of points, here there is another point, power is the same. Here there is another point, power is the same. All these points lie on a straight line. That line is called radical axis. You can take any point on this line. The power of that particular point with respect to the two circles remains same. Then that line is called the radical axis. The equation of the radical axis is S minus S dash is equal to 0, because we are saying S11 is equal to S dash 11. What is S11? S11 is nothing but x1 square plus y1 square plus 2g x1 plus 2f y1 plus c is equal to 0. is equals to, that is s dash, s11 is equal to s dash 11. Same, x1 square plus y1 square plus 2 g dash x1 plus 2 f dash y1 plus c dash. S11 is equal to s dash 11. Now x1 square plus y1 square, x1 square plus y1 square cancel. If you shift to this side, then you will get 2x1 into g minus g dash plus 2y1 into f minus f dash plus c minus c dash is equal to 0. Now we want to find out the locus of a point Px1 y1. That means in place of x1 y1 we have to write x comma y. Therefore 2 into g minus g dash into x plus 2 into f minus f dash into y plus c minus c dash is equal to 0. This is the equation of radical axis, which is nothing but s minus s dash is equal to 0. Right? So the locus of all points whose power with respect to these two circles remains same, then the locus of all these points is a straight line. That straight line is called radical axis. Observe here, we got the radical axis. This is one circle and this is another circle. This circle equation is s is equal to 0 and this circle equation is s dash is equal to 0. That is the radical axis we got. Now this is line joining the two centers of the circles. No doubt you know the center of this circle and you know the center of the circle. Just now we got the radical axis equation as s minus s dash is equal to 0. Radical axis is always perpendicular to the line joining the centers. If the two circles are intersecting, then this common chord is the radical axis. The equation of that common chord is equal to s minus s dash is equal to 0. If the two circles touch each other, then the common tangent, this is the common tangent. That common tangent is nothing but the radical axis, which is nothing but s minus s dash is equal to 0. Suppose you see this is one circle, this is another circle, this is one more circle. All these circles centers are collinear, lie on a straight line. This is the center. These three centers are collinear. Now this one what we are saying. Now for these two circles this is the radical axis. For these two circles this is the radical axis. When these centers are collinear, then the radical axis parallel, because as we know radical axis is perpendicular to the line joining the centers. Radical axis is perpendicular to the line joining the center. That's why these two radical axes are parallel. At the same time, this is one circle and this is another circle. There is a circle intersecting both the circles orthogonally. This circle intersect these two circles orthogonally. What is the meaning of orthogonally? This circle intersecting this circle at right angles. That means angle between these two circles is equal to 90 degrees. So the circle intersecting these two circles orthogonally, then the center of this circle lie on radical axis. A circle intersecting the given two circles orthogonally, then the center of this circle must lie on radical axis of these two circles. Right? So there are three circles whose centers are non-collinear. This is one circle and this is another circle and this is one more circle. The circles whose centers are not collinear. For these two circles this is the radical axis. For these two circles this is the radical axis. For these two circles this is the radical axis. The radical axis intersect at a point. The point of intersection of radical axis, this is called radical center. taking this radical center as a center, and from this center to any circle, the length of the tangent you can consider as a radius. So this is the radical center. CA is the length of the tangent from radical center. Taking this one as a center and this length as a radius, if you construct a circle, this circle intersect all the given circles orthogonally, right? Once again, taking the radical center as a center and a length of the tangent as a radius, if you construct a circle, that circle intersect all the circles orthogonally. So that is about few ideas related to the pole, polar, conjugate lines and radical axis and radical center. Okay, bye bye.